Hello and welcome back to Beginning C++ Programming. This week we're going to be talking about arrays and a little bit about strings, which work a lot like arrays. So, what's an array? That's where we'll start. If you think of a variable as a box, which is an analogy we've used in the past, that can hold a value, what if I need to can have like many variables? Like I have to have 100 different test scores, let's say. Should I create a variable for each one? I mean, they're all sort of the same thing. They're all test scores. So maybe there's a way I could create something that could hold all of those values, but in a way where I don't have to come up with separate variable names for everything. And so that's the idea of an array. If this is a box that holds pills, well, so is this, right? It's just that this is actually a number of boxes that are all referenced by an index. I could say, get me my pills for Friday. And you would know, well, I just go to the Friday box and I pull it out. Arrays are going to work in a much the same way. If one box can hold an integer, then I could have multiple boxes side by side, literally, connected in memory, sort of a continuous thing that could hold up to 100 different integers. And instead of indexing them by days of the week, because that wouldn't make any sense, we're just going to use numbers for indexes. So I could say, give me the 7th test score, or how about index 7 test score, or index 8 test score. I'll say why we don't say the 7th here in a second. So, how do we create these? In C++, to create an array, it's very similar to creating a variable. You just have to give a type, right? So in this case, it's going to hold an integer. The name of the array, whatever you want to call it, right? Test scores, whatever. And then in square brackets, the number of boxes in the array, the number of integers you actually want to store. So this array will hold up to 16 different integers. You can make that size whatever you want. It's kind of arbitrary, but ideally enough to do your work. Now, once you create an array, by the way, of a particular size, it's going to always be that size. You can't shrink it, you can't grow it. There are other collection classes in C++ that will allow you to do that, but this is not one of them. And at this point, especially for electrical engineering majors, knowing and how to understand like native arrays, sort of the simplest prototypes or simplest, form of an array is really important. So here we create int scores 8. That creates a sort of continuous part of memory that will hold up to 8 different integers. Now, by the way, I'm showing them as blank, but that's actually not true. C++ doesn't actually zero out all the values like other languages do. If you wanted to do that, you would have to ask for it. C++ doesn't do anything you don't ask it to do. That's an advantage and a disadvantage. Because in general, we'd probably want to zero out those values, meaning that you could be given memory and there's already values in there, whatever's in there. So if I were to say, try to access the second index in this array, I would get a value, even though I didn't put one in there. It's because there was one there already. Probably a very large negative value for some reason. The other thing to note is how these are actually indexed. In computer science, almost everything starts with 0. So the first element is actually index 0, scores sub 0. The reason for that is that sub number, that's how we would say it in English. This would be, if I wanted to access the first value, I would say scores sub 0. 0 being in the square brackets. That's the first one because that sub number, the index number, is actually sort of a memory offset. So I'm saying go to the scores address and just start there. Don't go up any. Since integers take 4 bytes, if I said scores sub 1, then it would be, okay, so then go up 1 integer or up 4 bytes to the next value. And so that's kind of what that number represents. Regardless, int scores 8 is going to create an array that can hold 8 different values. If I wanted to, I could initialize those values with an array literal. An array literal is just curly braces with all the values put in separated by commas. So here I can put in 8 different scores, and those scores will be put in. Now for testing purposes, this is really convenient, really helpful. In the real world, it probably has a little less value because where did these scores come from, right? Generally, you're going to be getting the values in your arrays from maybe a file or some sort of user input, something, right? They should have meaning at the moment. Here, we've just put in an array of 8 scores for testing purposes, maybe. But there is a form of initialization that is helpful, and that's this. Remember how I said C++ doesn't zero everything out for you, so those values are still there? This will zero out everything for you. Basically, if you don't put in the right number of elements, right? So like score sub 8 equals, and I just have the array literal for just one value of 0, it's going to assume that value for all of the other values. So this will actually zero out everything in your array for you. So fairly helpful. Then you have predictable answers if something goes wrong. So then, how to actually assign a value to something in the array? I could just say scores sub 2 equals 76, right? I'm using the assignment operator, right? Just like I would anything else. This is the same as assigning a value to a variable. It's just that my variable has this sort of sub-notation at the end of it to give the index of which position in the array I want to place it. In this case, it puts it in index 2, which is the 3rd element in the array. I swear that will eventually become second nature to you, and it won't be confusing at all. But right now, it will be. Index 2. Now, how do I retrieve a value from an array? Pretty much the exact same way, right? Here I'm going to assign it to a variable called highest score. If I want to retrieve a value, I just go scores sub 6. This would be the same if I wanted to print it to the screen. I would just do cout arrow arrow scores sub 6, and that will give me the 7th element in the array. Yeah, you can use that sort of combination of array name and index number just like you would any other variable in your code. Now, arrays and loops go together like a horse and carriage, which is a popular thing from a TV theme song that none of you would know of at this point. But anyway, so if I have an array and I want to traverse that array, traverse is just a fancy word for sort of go through it, element by element, right? So if I wanted to traverse the array, go through it, I could use a loop, right? And what that loop will allow me to do is I can, standard for loop. For int I equals 0, I less than 5, I plus plus. And here I'm wanting each iteration of the loop, I is going to change, right? I starts at 0, then it moves up to 1, then 2, then 3, then 4, and then never 5. I said I less than 5. That's going to be important here in a second. But the idea is that because with each iteration of the loop, I is going up, that means that scores sub I, the first time we go through this loop, that's going to represent scores sub 0. That's the first element. Second time, it's going to be scores sub 1. That's the second element. Scores sub, it's just going to keep going through each element of the loop. And so here, this will print out on separate lines every value in my array. My array that holds 5 elements. Now here's sort of the big thing with loops, because you will get crashes if you don't. C++ doesn't have any sort of bounding, right? So like you can actually go off the end of an array. And when you do that, it immediately causes a crash. And the reason for that, we'll talk about in a second. But the idea is that you can't go past the end. So usually you put in int I equals 0, I less than whatever the size of that array is. In C++, arrays don't know how big they are, which is kind of a problem. The newer STL versions of arrays do, but not the native. And so what you have to do is, put in the, but then use a less than, not a less than or equal to. You never want to get to 5, because even though the size of the array is 5, its indexes are 0, 1, 2, 3, 4. Scores sub 5 would actually be the element off the end of the array that doesn't exist. It's some other piece of code, and you're going to get an out of bounds error. So if you ever get an out of bounds error, check to see that you're not going off the end of your array. There's some ways to sort of handle that, right? One is just create a constant. So if you create a constant and you say array size equals 5, then when I create the array, I just use that constant array size. So it'll be there. And then when I loop, I can just use array size, and that's fine. It's a solution to it. If I ever need to, have more ability to hold scores, I can just increase the size of the array in one location, and it changes it everywhere, which is an advantage. If I did this hard-coded 5 in all these different locations, then I've got the problem of, oh yeah, I'm going to change the size of my array to 5. Oh, but I forgot someplace where I actually had a for loop to change that value as well. So instead of getting the average of all 20 students, I'm only getting the average of the first 5. That's not helpful. Anyway, point being, constant is a way to solve that. You can also just use a range-based for loop. This works so long as it's within the same function, but so for int x colon scores, we would say for int x in scores. A lot of times we actually say for int score in scores, and then you go through and then you just use x. What this is doing is it's actually going through the array, traversing it, copying each value and assigning that value to x. So then you can then use that for whatever you're calculating in your loop. So here I'm just printing stuff out to the screen, but I could be adding up all the different values, to find the average. I could be doing anything, but remember, I'm copying the value from the array. That means that there's a whole bunch of times where you cannot use a range-based for loop. One is anytime you need to change the contents of the array elements. If I take this value and I assign it to x, and then I change x, that just changes the thing that I'm using to hold onto the values. It doesn't actually change the original array, unlike using the index number does. That will actually change the values in the array. So if you want to actually change the contents of the array, you have to go with this, I say the old for loop, the standard for loop, right? Not the range-based for loop. Although range-based for loops are newer, they're not necessarily more common or better. If you need to go through the array in reverse, can't. It goes through front to back, you don't get a say. If you need to skip around in the array, same thing, you can't do it. It's first element to last element. Now you could put in some sort of a conditional so that you only do something to particular values when you see them, but you can't change the order in which you access the members of the array. The other thing you can't do is if you need to access 2 arrays at once, you technically could, but then you'd be putting in like a separate counter, which means at that point you might as well be using the standard for loop, which would do it a lot easier and cleaner. But you could theoretically keep track of a counter to access another array using index numbers. And obviously if you need to refer to the index number of the element, you can't, because that's the thing you got rid of, right? You're not actually going through 0 through whatever the size is. You're just saying, hey, go through it yourself and then just tell me, here's an integer you can just use to copy those values into as you go. So you don't actually have a number. Again, you could calculate it, but if you're going to, actually increment a counter every time you go through that loop, then you should have just done the original for loop. That's what the for loop does. Anyway, so potential problems with arrays. One, they do not have a function or a property to hold their size in C++ for native arrays. And then it's just because it literally is just, I'm assigning memory and, just if I need, 10 arrays, if I need 10 integers in an array, it's 4 bytes per integer. I'm going to just assign 40 bytes, and then we just use that subnotation to give us what the offset should be for each value. It's really, really primitive. They don't have, other languages will have this size of the array, which means that when you, let's say, create functions next week, and we have to send an array, you probably also are going to need to send the size. They don't perform bounds checking, which means you can actually go off the end of the array. That's kind of a problem. It kind of gets shut down these days, but it was kind of it's a problem in the past. Just Google buffer overflow exploits, and you'll see all sorts of stuff pop up. There is a way, by the way, of calculating the size of an array without having to actually, create a constant or do any of that. The problem is, in practice, it has less use, only because it only works when the array is actually created right there in the when the array is created right there in the thing that it's in the function that it's done. The problem is you don't know what function. I mean, you kind of know what one function is, main. So long as it's in main, right? At this point, you're fine. You can do this. But the second you start creating other functions and you start passing arrays to those functions, then you might have a bit of a problem. There's some ways around it. You can kind of use this programmatically, but anyway, for right now, you don't have those tools yet. But you can Right now, since you're just using the one function, do this all you want and it will work every time. To get the size, like the number of elements in an array, you can use the size of keyword. So the size of, I say keyword, it's actually an operator in C++. So the size of operator will return the number of bytes that something takes. So here I say I want the size of scores. Now, once you pass this to another function, what you're sending is just the address where scores starts. But inside of this scope, this function, the main function, it will give you the size of the entire array, which means for something that holds 10 integers, it'll give you 40 bytes. That's the size of scores. You just divide that then by the size of scores sub 0, which is the first element, which is only 4 bytes, and 40 divided by 4 is 10. Gives you the number of elements in the array. Again, it's got some limited use. You can kind of flip it. You need to use some skills for it. But for right now, it's a great way to calculate the number of elements in an array. Now, strings. Strings are going to work a lot like arrays. For instance, here is a C-style string, right? This is what C has been using forever. It's really just a character array, right? I have a list of characters, and those characters will end with something called the null character. That's that \0. It represents nothing, right? It represents, in this case, the end of my string. So I could actually traverse the string, the character array, until I found the null character, and then I would know I was at the end. And that's the way strings have worked in C since, 1969, right? And so here I've got a string baker, and it's actually literally creating an element that has, B-A-K-E-R, all separate characters terminated by a null character. So we could use that if we wanted to. Here's a character array called name. Enter your name, do cn. Hey, ahoy there, name, and that works. So long as your name only has one word to it. If you were to put your last name in there, this wouldn't work, and that's because the sort of trappings of cn. There is actually a way to get it to work with these C-style strings. You would just use cn.getline, but I'm going to show you the other version of Getline here in a second, and that's the one I think is probably better because we're in C++, and you might as well just use the string class. So C++ has a different way of handling strings, and so all you have to do is include the string library, and that's going to give you access to the string class with all of the different features that are available to strings. Then, when you create a string, you can just say string name equals whatever, and then, print out. You still have access to use indexes like you would with C-style strings. So name sub 2 of that string, in this case, would return 0, 1, 2, the lowercase n at the end of Dan, right? Done. You can still access the individual characters using array notation, just like you could with C-style strings. But you also get other things, like, for instance, the string class is overloaded to handle the plus operator. Except here, obviously, we're not adding anything. We're going to do something called concatenation, which is a fancy computer science term for taking something and shoving something else onto the end of it so that it makes it bigger, right? So in this case, I'm going to take uncle, which is Rick, plus the string space ampersand space, and then kid, Morty, and shove it all together, right? Like stringing popcorn on a string to put on a Christmas tree. I don't think people actually do that anymore, but regardless, right? I am just sticking stuff together and making a bigger string. The plus operator will work so long as the thing on the left and the thing on the right are both strings. So you can concatenate strings together. Strings know how big they are. So you could just say, hey, I've got a string called uncle, so what's uncle.size? Uncle.size happens to be 4, right? There's 4 characters in that string. And if there's a null terminator, we're just not going to count that one. We're going to count the ones that actually matter. Now, with strings, we also get access to this new function called Getline. Getline is the way I prefer to get information from the user rather than cn, because it grabs everything as a string, and what they're actually typing onto the keyboard is a string. So you know that it's going to be at least a valid string. You're not going to get a crash here. Later on, when you try to interpret or convert that into, like, let's say a number, you might. But then that's where you have that exception that you can use to make sure you get what you want. In this case, we're going to use Getline, and Getline has, well, it has 3 different options, but the first two parameters you sort of need to fill in. One is, where do you want this to come from? In our case, from the CN, from the console in, the standard input, the keyboard. Where do you want it to go? Well, that should be a string variable of some sort. I often put it into a string called temp because I'm usually grabbing stuff over and over again just temporarily so that I can convert it into something else and send it wherever it needs to go. And so that's really nice, right? I can basically use this like CN, but instead of going to the first white space character, so if I typed in Brian Baker, it wouldn't go to the space in Brian and say, oh, well, that's what I'm going to capture. It's actually going to go all the way to the new line character, to where I actually hit return. It's going to grab that entire string, put that into name, and it's going to conveniently remove that new line character from the input buffer so it doesn't come around again if I try to ask for another string later. So Getline, a lot of features that are really nice. But there's a third optional parameter you can use. Actually, here's an example. Enter your name, Getline, ahoy there, name. And even if your name is, 73 different words all put together with spaces and whatever, until you press return or enter on a PC, it's going to grab that entire name and put it in there, right? So you're good to go. Now, Getline has a third optional parameter, which is actually the reason I like it, because eventually we're going to start talking about file I/O. And one of the most common ways of storing data in files is called a CSV file, comma-separated values file. What this does is, by default, Getline captures all the way to the new line character and then grabs whatever comes before the new line character and eliminates the new line character from the input buffer. But if you want to, you can change which character you use to stop at. So in this case, I'm going to get from the CN, although it's coming from the CN. Eventually, when we start using files, you could use it from a file. It will grab everything up to the comma. It will put that into something called name, and then it will remove the comma from the input buffer. So if you were to have, let's say, a whole bunch of data just separated by commas, you could use this inside of a loop to go comma by comma and grab all the different bits of data in between the commas. Just trust me, this is a lot easier later on. So here we go. I've got 2 strings, first name, last name. Now, granted, there's a bunch of names this won't work for still, but for most names, it's going to work. Enter your full name, Getline from the CN, first name up to the space. So long as you don't have a space in your first name, we're fine. And then Getline CN into last name all the way to the new line character. Notice that these are characters, single quotes, not strings, double quotes, right? We're going to be getting strings, but we're looking for a particular character to stop at. And so that would, for Brian Baker, work. Ahoy there, Brian. It would know my first name and my last name. You've kept them separate because, there's just the space in between. Technically, you could do the same thing with CN by using another arrow, but whatever. Over time, Getline is a little bit more functional. But in addition to that, I would still have the last name that I could use someplace else. Now, again, there are names that would kind of break this. I had a friend whose last name was Van Patten growing up. It had a space in the name. So it's just going to grab the Van part and leave the Patten part, which will just be still in the input buffer. But regardless, you get a little bit more flexibility with Getline. Now, let's talk about some fancy arrays. These are really just some strategies you can use when creating arrays that might be useful for particular things. The first is just parallel arrays. Parallel arrays are pretty simple. I've got 2 different sets of data that I want to keep together. Let's say, for instance, test scores and somebody's name, right? So because I want to know who scored what. I could do this through something called parallel arrays, which basically just means that for any one index, right, the names array, like that person's name, should match the person's score in the scores array. So here, for instance, I've got an array called names, John, Paul, George, and Ringo, scores 98, 82, 93, 67. Don't know why everybody always bags on Ringo, but whatever, that's fine. And so here, John scored 98, Paul scored 82. We're keeping all the values in parallel. And the only thing you need to remember with parallel arrays is that if you ever make a change to one array, you have to make the same change to the other array. If I want to flip George and Paul, fine, but I also have to flip the scores array for the same indexes. Otherwise, they won't stay lined up, right? I want to move George up into position to, let's say, put these in order. When I switch George and Paul, I need to switch their scores as well. Otherwise, I have completely corrupted my data. Make sense? Parallel arrays, really simple, but kind of tedious sometimes just to remember what you have to do. The other thing is a 2D array. So a 2D array is really just an array where every element in that array is another array, right? And so here I've got, let's say, and by the way, you can visualize this in either way. For me, the first number are the rows, but you'll see other textbooks and other people who describe the first number as representing the columns. So this is the original array and this goes down. How you visualize it is up to you, right? I mean, if you don't like the way I visualize it, just tilt your head to the side and you're fine. I guess in this case, tilt your head to the side and look at it in a mirror and you'd be fine. But, you know, for me, the first array is kind of going top to bottom, right? 0, 1, 2, 3. So those are the 4 elements of my array. What is going to be in each of those arrays? Another array. This one holding 6 elements. Although, sorry, not 6 elements. This one holding 8 elements. 0, 1, 2, 3, 4, 5, or 6, 7, right? So 4 elements in the first array. Each of those elements is another array that holds 8. This is really great for holding tabular data, right? I can traverse my different rows, go through each value in the rows, so that I can, you know, do whatever I need to do. And so 2D arrays are, yeah, it's great for tabular data. When you're wanting to traverse 2D arrays, oh, sorry, how do you declare a 2D array? How about we start with that? If you want to declare a 2D array, you just int a 4, which is going to create your first array that holds 4 values, and then each of those values is going to be 3, right? So you get 3 elements in each of the arrays inside of those 4 different arrays that you've created. So a little table. You can initialize if you want to, right? Because it's a sub 4, there's going to be 4 elements. Each of those 4 elements will itself be an array that holds 3 elements. I almost kind of like showing this initialization just because it's another way of visualizing what you're actually doing. It's just an array of arrays. Then, when you want to play with 2D arrays, as we alluded to in the loops lecture, you're going to use nested for loops. And that's because for every iteration of the outside loop, you're going to execute every iteration of the inside loop. So the outside loop is going to iterate over your rows. The inside loop is going to iterate over all of the different elements in each row, right? Each column, but it's the elements just for that one row, column by column. And so then, yeah, 2D arrays are the way to do it. Now you're saying to yourself, well, wait, for loops also have an easier way of traversing using the range-based for loop. Can I do that with a 2D array? The answer is yes, but there's going to be something weird, which is that first thing that you get back, the type, is going to be an array of integers. And there's no real way to express that easily with C++, but C++ has that auto feature. And so we're just going to do an auto alias row. Now, references and pointers are coming later, so you just have to trust me on that little ampersand of touching the row. But we're using the auto to just say, hey, whatever type is inside of sales, which is going to be integer arrays, give me the address of those things. Don't worry about the address part yet. That's the part that you don't understand with the ampersand. But like just whatever that type is, just let's go through each element of sales. Well, each element of sales we know is an integer array. So now for the inside one, I can just say for int n inside of row, right? Because row is the thing that I'm going through. Each time I grab an element from sales, I'm calling it row. And then I can just go through the row and access each individual element, which is going to be an integer. So this will work for 2D arrays using a range-based for loop. It just involves a little bit of witchcraft that you don't quite understand yet. But, you know, that's fine. In computer science, there's always something that's witchcraft. Don't ask me how you get, you know, water to ripple when characters walk through. That's calculus I don't understand. And that's it. Arrays, strings, sort of our first collection thing, and that's going to allow us to be able to handle more data. So if you have any questions, send me a message through Canvas, and I will see you online.